So I'm going to start off talking about JavaScript and specifically what we're doing on performance. Like all developers, we're obsessed by making things faster and making things more efficient. And when we think about it with the JavaScript API, we think about it in two ways. How do I get the data from the server to my browser as efficiently as possible? And once it's in my browser, how do I use it? How do I draw it the most efficient way? And then can I use it with client-side engines so I don't have to always go back to the server to perform certain tasks? So for both of these, we've been making good advancements. We now can request both pre-rendered vector tiles as well as feature layers in tile formats. And by requesting them in tiles, we can cache these requests on the server so it doesn't always have to go back to the back-end database to get the features. And that greatly improves performance and makes them much more scalable. For 3D data, we've made enhancements to the 3D format that we use, the I3S specification, again, to improve the efficiency on how we retrieve the data. In terms of rendering it, all of our layers are now rendered using WebGL for the best performance possible in a browser. And we've worked on our client-side processing engines, our geometry engine, projection engine, the SQL engine, all running inside of the browser on the client. I think the best way to look at this is with some demonstrations from my colleagues back in Redlands.
One of the areas we've done a lot of work in to improve performance has been our vector tiles. So here we have a demo of vector tiles loading in version 4.10 and 4.13. As you can see, the speed of loading the vector tiles is between 30 to 40% faster than it was before. Now these are vector tiles of OpenStreetMap data, which contains a lot of really dense features. So it's a lot of information that we have to draw. And the way we manage this is by downloading all the tiles in parallel and running the rendering work in parallel as well. Along with the work that we've done to improve the performance of vector tiles, we've also improved the performance of the feature layer. Here I have a feature layer of kilometer markers in Spain. What's interesting is that these markers are not lines, they're points. It's just so packedly condensed they look like lines when you're viewing them on the map. You can see that I'm drawing these tiles on the map. And what these are the tiles I'm using to request the data from the service. And what we do is that if we can't get all the features in a single tile, we'll break it down to need even more tiles so that we can request that data. This makes the request cacheable. Now because we are bringing in all this data much more efficiently, we're able to download it quickly, we're able to draw these features very quickly on the map and have everything available to us in the client, we can do some pretty interesting things. Here I have a data set of temporal anomalies for the entire globe from 1880 to 2018. This particular feature layer has 120 fields in the table. And I'm rendering these fields using a renderer with visual variables. And one of the things I want to do is I want to update the size and color visual variables for this renderer every time I adjust the slider, so I can view the data set at different points in time. You can see here that as I go ahead and update my slider to scroll through different years, I'm updating this data on the map incredibly quickly. And this is because we're actually saving the attribute data on the GPU, so we can go ahead and update these features incredibly efficiently and incredibly fast.
Besides rendering improvements, we also worked on performance. I3S, Esri's open standard for streaming large amounts of 3D data, now uses oriented bounding boxes and geometry compression. By supporting the latest version, the JavaScript API now renders scene layers twice as fast. You can see this in the video with the most recent API on the right, comparing the loading times of different viewpoints on an integrated mesh. To benefit from these performance improvements, make sure to update your existing scene layer caches to the latest version of the I3S specification. A helper tool is available in the public GitHub repository of the specification.
So that was just a couple of quick demonstrations there from the team back in Redlands. Moving on to visualization and the interactivity that you can put into your applications. You saw some of this being demonstrated with the new map viewer. The new map viewer is built on top of the latest version of the JavaScript. So we've got our data-driven visualization. It's integrated both in 2D and in 3D, and we've improved certain aspects of that. GeoJSON is now a first-class citizen of the API. It's very easy to bring GeoJSON data into your application. We've got smooth vector symbols that scale beautifully, no matter what scale you're at, and we've got improvements in our time-based support. So what I'd like to do is pass over to Julie from the JavaScript team, and she's going to give us a demonstration of some of these new capabilities.
I'm going to start by talking to you about vector style symbols for 2D. Now this is a very simple application, just showing points of interest. But as I zoom in, you can see these symbols remain crisp and beautiful, regardless of the scale. And that's because they're vector symbols. The API now comes with more than 100 vector symbols that you can simply use by referencing them by name. So check them out in the guide, click on the one you like, and then you see how you can access it from your application. This is a simulation of taxis driving in New York City. The lines animate along the path from blue at the start of the journey to red. And this glowing animation was generated using a custom layer view and WebGL. Now one day this will be out of box along with many other new visualization styles. But the API is set up to give you the freedom to create any visualization you want on your own timeline. As shown earlier, you're not only working with a pretty picture on the client, you have access to the features all straight from the source. This allows you to build very interactive applications. One way that we traditionally interact with data is by filtering. We do it based on some criteria and remove anything that doesn't meet our filter from the map. In this app, we're able to do a little more than filter. Rather than remove the features that don't meet their criteria, I can de-emphasize them by leaving them on the map for context alongside the features I do want to draw attention to. So here I'm emphasizing hydropower plants. Now this is actually a web application template called Interactive Legend. As we add new capabilities into the API, web apps throughout the platform start taking advantage of them. We're looking at earthquakes. In this case, we're using the API's GeoJSON layer. GeoJSON is a first-class citizen in the API. To use it, I simply define the layer and then point to the URL where the GeoJSON feed is. I can define a template and then style the layer however I'd like. You also have access to all the client-side querying statistics that you saw in the previous applications. So in this case, we're pulling down all the earthquakes from USGS that happened in the last month, finding the largest earthquake, and then all the earthquakes that happened in that same week around the same location. Let's have a look. This is actually a 3D application. So what I can do is look underground and play the time slider to really understand the movement that's happening underground in the same time of that very large earthquake. So as you can see, all the capabilities that I've been showing aren't limited to 2D. In fact, they're all available in 3D.
Great. Finally, for the JavaScript, how do you build great user experiences? You often start with one of the widgets that we create. Now, last year at this time, we had over 24 widgets that were available to you as developers that you could incorporate into your applications. Today, we have over 40 widgets available. So there's a lot of development effort happening in this area. And you're actually going to see many of these widgets come to life in the new map viewer, because it's built from the same technology that you use to build your own custom web applications. So that was JavaScript. Onto the Runtime SDKs. It's what we build to support you building native applications. We've done work across the entire spectrum of the Runtime, but perhaps not least is our support for offline capabilities, and we've added a number of key enhancements there. Now, the Runtime team releases 3 times a year, and every release that they produce has a significant set of capabilities. So I would encourage you to stay up to date with the work that's being done, because there's an awful lot of new functionality that's being rolled out there. And we determine what work we're going to put into the runtime based on your needs. And the two key industries that we really see picking up the runtime and using it a lot is the utility industry, as well as defense and public safety. So these are the two industries that are really driving our development efforts for the runtime. Working offline, it's the key differentiator for runtime. We've been making enhancements to our offline workflows so they scale very well. You can now go offline, not with tens or hundreds of workers every day, but you can go offline with thousands of workers every single day, very scalable solutions with our pre-planned workflows. You can use navigation inside of your applications, similar to our own application, the Navigator app. That functionality has been moved down into the runtime and is available to developers. And just released last month was our support for augmented reality. So you can now build augmented reality applications for Android and iOS using any of the toolkits that we support these two operating systems from. It's going to allow you to build completely new user experiences for the problems that you're solving with your applications that you're building. Finally, let's take a look at the .NET SDK for ArcGIS Pro. The team's been adding a lot of small enhancements across the entire surface of the API, but this last year it's released two brand new APIs that expose capabilities that are available to end users in the application. The first one is scene layer support, and the last one is stream layers. So this is bringing real-time data into your applications, but for the first time you'll be able to work with that as a developer and an API. So with that, I'd like to pass back to Narit. Thank you.